Hello students, this is Sujata coming with class 10 NCERT SSC Math with Sujata ji. Now let us see the topic nature of the roots of a quadratic equation. Okay, now in the last lecture we studied about how to find out the roots of the given quadratic equation. Now the roots is also known as the solution of the given quadratic equation. So we have to find out here now the nature of the root. Okay, so let us see that if alpha is equal to minus b plus square root b square minus 4ac upon 2a and beta is equal to minus b minus in the square root b square minus 4ac upon 2a, then we say that these are the roots of the given quadratic equation ax square plus bx plus c is equal to 0. Okay students, now here if these are the roots of the quadratic given equation, then we can say that first condition, that is if b square minus 4ac is equal to 0. Suppose the value of b square minus 4ac is equal to 0, then we can say that the alpha is equal to minus b plus or minus in the square root 0 upon 2a. That means minus b plus or minus 0 upon 2a, and that means minus b upon 2a. Okay, so here our both the roots are equal. Okay, alpha and beta are equal. So here we say the roots of the quadratic equation are real and equal. Okay, so this is the first condition, that b square minus 4ac is equal to 0. Then the nature of the root will be real and equal. Now here, then second condition, if b square minus 4ac is greater than 0, then greater than 0, that means the value should be in positive. Okay, so here x is equal to minus b plus or minus in the square root b square minus 4ac upon 2a. Then this is alpha with plus sign and this is beta with minus sign. So these are the two roots of the quadratic equation are real and unequal. Here we say that we get the values, we get the solution as a separate, that means they are unreal and we have the values real. So the nature of the roots are real and unequal in this condition. Now third condition, that if e square minus 4ac is less than 0, then we say that the x is equal to minus b plus or minus in the square root b square minus 4ac upon 2a are not real numbers. So that means the roots of the quadratic equations are not real. So this way we can understand the nature of the roots of the given quadratic equation. Now here that the b square minus 4ac is called discriminant of a quadratic equation and is denoted by Greek letter delta. Okay, if you find out the value of b square minus 4ac, that b square minus 4ac is called as delta, represented by delta, and it is called as the discriminant. Activity: fill in the blanks, value of discriminant and nature of roots. So here in the first column, give us the value of discriminant and we have to find out the nature of the roots. So here the value of discriminant, that means the value of b square minus 4ac is equal to 5. Is equal to 5 means b square minus 4ac is greater than 5. Positive value. So we say that the nature of the roots are real and unequal. Okay students, and here the minus 30, that means b square minus 4ac is equal to minus 30 and minus 30 means which is less than 0. That means we say that the nature of the roots are not real. And here the value of discriminant is 0. That means the nature of the roots are real and equal. Now let us see the next example, students. Find the value of the discriminant of the equation x square plus 10x minus 7 is equal to 0. So now here the given quadratic equation is x square minus x square plus 10x minus 7 is equal to 0. So we compare this quadratic equation with ax square plus bx plus c is equal to 0. That means a is equal to 1, b is equal to 10 and c is equal to minus 7, students. Now here b square minus 4ac is equal to square of 10 minus 4 multiply 1 multiply minus 7. So the square of 10 100 and the product of these minus 28. So minus of minus 28, that means the plus 28. So the b square minus 4ac is equal to 28. The next example, determine nature of roots of the quadratic equation. Now here we have to step out the next one step out, that is finding out the value of the determinant and then you determine the nature of the roots. So let us see the compare 2x square minus 5x plus 7 is equal to 0 with ax square plus bx plus c is equal to 0. Then we have a is equal to 2, b is equal to minus 5, c is equal to plus 7. So b square minus 4ac is equal to square of minus 5 minus 4 multiply 2 multiply 7. So here square of minus 5, that means 25, and the product of these, that means 56. So 25 minus 56, which is equal to minus 31. So now minus 31, that means b square minus 4ac is less than 0. So if it is less than 0, then we say that the nature of the roots of the equation are not real. Then next example, students, x square plus 2x minus 9 is equal to 0. Now compare x square plus 2x minus 9 is equal to 0 with x square plus bx plus c is equal to 0. Then we have a is equal to 1, b is equal to 2, c is equal to minus 9. So b square minus 4ac is equal to square of 2 minus 4 multiply 1 multiply minus 9, then square of 2 4, and the product of these minus 36 minus of minus 36, that means the plus 36. So 4 plus 36, which is equal to 40. The 40 means greater than 0. Greater than 0 means the nature of the roots of the given quadratic equations are real and equal. The next example, root 3 x square plus 2 root 3 x plus root 3 is equal to 0. Then compare root 3 x square plus 2 root 3 x plus root 3 is equal to 0 with ax square plus bx plus c is equal to 0. Then we have a is equal to root 3, b is equal to 2 root 3, c is equal to root 3. So here b square minus 4ac is equal to square of 2 root 3 minus 4 multiply root 3 multiply root 3. So here square of 2 root 3, that means 4 multiply 3, that is equal to 12. And the product of these 4 multiply 3, that means also equal to 12. So 12 minus 12, which is equal to 0, and that means the roots of the equation are real and equal. Now let us see the relationship between the roots of the quadratic equation and the coefficient. Okay. Now here the alpha and beta are the roots of the equation ax square plus bx plus c is equal to 0. Then we can say that here the alpha plus beta is equal to minus b upon a. There is a relationship between the roots and the coefficient. Here the roots are alpha and beta and the coefficients are a and b. So there is a relationship between the alpha and beta and a and b. So here first one, that is the relationship between, for the sum, that is alpha plus beta is equal to minus b upon a. And for the product, the relationship is alpha beta is equal to c upon a, students. Okay. So now activity, there is an activity that fill in the empty boxes below properly, that is for 10x square plus 10x plus 1 is equal to 0. So now here, student, we have to write that alpha plus beta, we have to calculate the alpha plus beta. That means here formula is minus b upon a. Now the minus b that minus b means the coefficient of x, that means 10, and here the product sign is minus, and the a means the coefficient of x square, and that is equal to 10. So here alpha plus beta is equal to minus 1 student. Okay, and here alpha beta, that means the formula is c upon a, and here the value of c, that means a constant is 1, and the coefficient of x square, that is the value of a. So 1 upon 10 students. Okay, so now this way we can complete the activity. Now the next one example, that is if a and b are the roots of the, here we can write here alpha and beta. These are the alpha and beta. Okay, alpha and beta are the roots of the quadratic equation 2x square plus 6x minus 5 is equal to 0. Then find alpha plus beta and alpha into beta. The given quadratic equation is, students, 2x square plus 6x minus 5 is equal to 0. So compare this equation with ax square plus bx plus c is equal to 0. Okay, so now here a is equal to 2, b is equal to 6, c is equal to minus 5. So that alpha plus beta is equal to minus b upon a. So minus of 6 upon 2, which is equal to minus 3. So now alpha into beta, the formula is alpha b c upon a. So here minus 5 upon 2. So this way we can find out alpha plus beta and alpha into beta with the help of the values, that is the coefficient a, b and c. Okay students? Now let us see the next example. The difference between the roots of the equation x square minus 13x plus k is equal to 0 is 7. Find k. Okay. Now here the given quadratic equation is x square minus 13x plus k is equal to 0 student. So compare this equation with ax square plus bx plus c is equal to 0. That's why we can get the value of a, b, c. So a is equal to 1, b is equal to minus 13 and c is equal to k here. So now alpha and beta, let alpha and beta are the two roots, be the two roots of the given quadratic equation. Then there is a relationship alpha plus beta is equal to minus b upon a, and that will be minus of minus 13 upon 1, that will be equal to 13. And the second relationship between is alpha. So here now there is no need to take the second relationship. Here the alpha plus beta is equal to 13 called as the first equation. And here given, in the example given is the difference between the roots. Difference between the root. If we let the alpha and beta are the given roots, then the difference is alpha minus beta, and that will be equal to 7. So here second equation is alpha minus beta is equal to 7. Call it as the second equation. Now we have the two equation. So let us solve this equation, that adding 1 and 2. So alpha plus beta is equal to 13. Alpha minus beta is equal to 7. That addition. So alpha plus alpha, 2 alpha. Plus beta minus beta, that is equal to 0. And 13 plus 7, that is equal to 20. So 2 alpha is equal to 20, alpha is equal to 20 upon 2 and alpha is equal to 10 students. So now put this value in equation 1. In equation 1 is alpha plus beta is equal to 13. So 10 plus beta is equal to 13 and beta is equal to 13 minus 10. So here student, that beta is equal to 3. So now take the relationship of the coefficient and the roots of the quadratic equation, that is alpha into beta is equal to c upon a. So 10 multiplied 3, which is equal to k upon 1. So 30 is equal to k, that means k is equal to 30. So this way we can find out the value of k as the given quadratic equation. Okay students? Now see the third example. If a and b, here again that there is a mistake, that is the alpha and beta. Alpha and beta are the roots of x square plus 5x minus 1 is equal to 0. Then find first alpha cube plus beta cube, and second alpha square plus beta square. So how can we find out? First that we have the quadratic equation. Given quadratic equation is x square plus 5x minus 1 is equal to 0. So compare this equation with ax square plus bx plus c is equal to 0. Then we have a is equal to 1, b is equal to 5, c is equal to minus 1 student. So now relationship between the roots and the coefficient, that is alpha plus beta is equal to minus b upon a, which is equal to minus 5 upon 1, which is equal to minus 5. And alpha beta is equal to c upon a, which is equal to minus 5 upon 1, which is equal to minus 5. So now here the first we have to solve this alpha cube plus beta cube. So the formula for this is in this bracket alpha plus beta whole bracket cube minus 3 alpha beta in the bracket alpha plus b. So here cube of minus 5 minus 3 multiply minus 1 multiply minus 5. So the cube of minus 5 is minus 125 students, and the product of these are the 15. So here minus 125 minus 15, which is equal to minus 140. Okay student, so cube of alpha plus cube of beta is equal to minus 140. So now second, that is square of alpha plus square of beta is equal to, the formula is square of alpha plus beta minus 2 alpha beta. So square of minus 5 minus 2 into minus 1, so 25 minus of minus 2, so 25 plus 2, which is equal to 27. So here this way we can find out the values. See the next subtopic students, to obtain a quadratic equation having given roots. Okay, so now here see, let alpha and beta, let alpha and beta be the roots of a quadratic equation in variable x. Then when two roots of equations are given, then quadratic equation can be obtained. Okay students, if we have the roots of the quadratic equation, then also we can find out, we can form out the quadratic equation. So there is a formula, that formula is x square minus addition of roots multiply x plus product of the roots. Okay, so addition of roots means alpha plus beta, and the product of roots means alpha multiply beta is equal to 0. So there is the activity based on this sujatag formula. So see the activity 1, write the quadratic equation if addition of the roots is 10 and product of other root is equal to 9 student. So here we can form the quadratic equation x square minus, that is equal to, here write down the addition of the root 10 and the product of the root 9, and it is equal to 0. So x square minus 10x plus 9 is equal to 0 is the quadratic equation. Okay. Now see the next activity. Second, what will be the quadratic equation if alpha is equal to 2, beta is equal to 5? It can be written as, so x square minus here alpha plus beta x plus alpha into beta is equal to 0. So that means x square minus alpha plus beta, that is addition of these two, that means 7, and the product of these two, that means the 10. So here x square minus 7x plus 10 is equal to 0, which is the quadratic equation that formed from the roots of the given quadratic equation. Next example students, obtain the quadratic equation if roots are minus 3 minus 7. So here let the roots, that roots are given. So we here let alpha is equal to minus 3. Okay students, alpha is equal to minus 3 and beta is equal to minus 7. So alpha plus beta is equal to minus 3 plus minus 7, which is equal to minus 10. And alpha beta is equal to minus 3 into minus 7, which is equal to 21. So now here we know the formula for that. Obtain the quadratic equation x square minus alpha plus beta multiply x plus alpha into beta is equal to 0. Now put the given values, that is x square minus of minus 10x plus 21 is equal to 0. That means x square plus 10x plus 21 is equal to 0 is the quadratic equation. Students, thank you for watching our videos. Achieve your success with us. I'm sure that you will get 100% success in maths. So watch our videos continuously, regularly. Like our videos, share our videos to your friends.